VPN, virtual personal network. So, anyway. So able to teach hugely greater numbers, and it's even more significant than that, because one of the things I'm trying to do is to kill off the teaching side of universities. So now that may sound quite threatening to Wei-Jin professors, because it threatens to cut their livelihood, and that's true. That's just one of the prices of the, what did Schumpeter call it, the creative chaos or the creative destruction of capitalism, the ongoing march of technology, and that's true. But from the point of view of the students, the advantages are enormous, as I was saying in the introductory video. From the student's point of view, you can rewind in a classroom, in a real-time classroom lecture. You can't do that. So if you miss something, it's gone. But with a video lecture, you can rewind and play it back as many times as you like until you understand it. Also, with large numbers of free profs, I label myself a free prof. It's my term. A free professor giving free high-level university lectures to the planet. That means that students can begin to avoid the ridiculous situation where a year's tuition fees at a top university like Harvard or whatever can cost 40, even 50,000 US dollars a year, which is just insane, right? Especially now that it's technically possible for free profs to create free lectures, and to higher level than what's typically taught even at the best universities. Right? So they just, I see free proffing as absolutely revolutionary. It will educate the whole planet and kill off this major expense for parents who, like 4 years of Harvard University tuition, that's $160,000. That's a huge amount of money, and all that will be got rid of by people like me. So in that sense, I feel what I'm doing is of great significance, and I hope many other, especially retired professors, will become free profs and put their knowledge into YouTube videos the way I'm doing. Now, this is a sort of pioneering effort, so I'm very probably making mistakes. So I would appreciate feedback from you on how to correct those mistakes. So please email me, profhugodegaris@yahoo.com. Please email me your constructive criticism so that the quality of these lectures can be improved. And the saying, 2 heads are better than 1. So you may think up ideas that I did not think of to make these lectures better. So I would appreciate some feedback. Okay, so please email. All right, so let's start. So I'll give three more examples of quotient groups, because that's what we've been talking about. So the first one is the set of integers, and the binary operation is simple addition. Okay, so we're just adding integers. That's our group, and the subgroup of this is NZ. What does that mean? This set here is 0 plus or minus n, plus or minus 2n, plus or minus 3n, and so on. Right? And again, well, it's a subset of this, or subgroup. Binary operator is again just simple addition. Okay. Now this group is abelian, right? You're just adding numbers, and a plus b equals b plus a. So this is an abelian group, and therefore all subgroups of this abelian group are normal. Right? That was one of the theorems we did this lecture. All subgroups of abelian groups are normal. Okay, so we know this subgroup here, and it is a group. That shouldn't be too difficult to show. Right? This is a group, subgroup, so it's normal. Okay, so this is normal. And what are the cosets of this subgroup? Cool. Yeah, this is your H, if you like, your subgroup of this group. This is your H here. So what are the cosets of this H? What are the cosets of this? Well, they'll be of this form. So these are just elements of your G. This is G. This is H. Right? So these here are just your elements of G, and we only need to have n of them, because if you go to n, or n plus 1, n plus 2, little n here, it'll just get absorbed into this, right? So we only have n of them, n cosets. Now, because this is normal, this subgroup is normal, therefore we know that a quotient group, factor group, is possible, is defined, right? And what is a quotient group? It's a set of cosets. Remember? That's what a quotient group is. It's a set of cosets, well, a group of cosets. And these are the cosets of this subgroup, this H, okay? And those cosets then become members of the quotient group, and therefore a binary operation must be defined on those members, because the quotient group is a group, right? Therefore you must have a binary operation on the cosets. So you need a binary operation on these cosets. And what is it? Well, it will be adding the cosets, right? So here are two general cosets, like just R is like either 0 or 1 or 2 dot 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 n minus 1, and S similarly. So if you just adding to any of these two cosets, you'll get this, right? So it's not too hard to see that your quotient group effect is just isomorphic to Zn, right? And what's this n? What is Zn? It's I could write it. So well, here's an example of Z4, right, where n is 4, and the elements are residue classes. Remember, they're just residue classes. So this is an infinite set of all integers that are, what's the word? Congruent to 0, mod 4, right? So here, this group, you'd have 0, 1, 2, 3, dot 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 until n minus 1, and mod n. So here's 4, so right, it has four elements. This will have n elements. Okay. All right. Now the next one, you can see it's a lot. Down to here, it's a lot of detail. So, in fact, once you have the techniques of this next example, example 3, you can apply that to example 4, which it's just as tedious, just as much involved as example 3, this one, but the techniques you use are much the same. So I've only used a small amount of space here to describe it. All right. So next example. So you have a bigger group. Well, this is an infinite group. Forget what I just said. Okay. It's not a small group, put it that way. So it's Z4, here's Z4, okay, times Z8. So you're talking about a factor group. So you're multiplying two groups together, and you then divide. You're creating a quotient group, factor group, and this is your subgroup here. Okay, so it too is a product group of Z4 times just one element. Now this is just one element of this one, right? Remember your subgroup is taken from this group. This is your G. This is your H. Your H is a subgroup of your G, right? So this second term here, after the times, this here is one of the elements of this. Okay. Now how many elements does this have? Well, 8. It'll be like this 0, and then a 1, a 2, a 3, 7. Okay. So this has 8 elements. This is just one of them. Okay. So in a sense, we're fixing this one. And these, there are 4 here. All right. So we're asked, what is this? What is it? As a quotient group, what is it? Well, firstly, what's this? The group itself, G. What is it? Well, so it's a product group, right? This is of this form. These are residue classes of this form. Now you can shorten that just as a kind of shorthand to this form. Residue classes behave very much like integers. They have very similar properties. So a typical shorthand is to instead of writing this, you rewrite it just as integers, right? Now in the context, this 0 here, strictly speaking, is the residue class of 0, right? Mod 4. You know what the mod is from the context. So rewrite this as this, okay? So therefore, Z4 times the product group, Z4 times this one element here, which I've just in shorthand just written as 0 here.